All right, here we go with 6.3 trig equations. More on that, right? So 6.3 trig equations involving multiple angles. And we already looked at what happens when we have a multiple of 2, like sine 2 theta. How do we solve for that? And we were using double angle formula to rewrite it. Okay, but now we're going to look at, okay, well, what if we don't rewrite it? How do we address them? Okay. All right, so take notes. Hopefully you are keeping up with the homework and checking in for attendance. All right, 6.3 trig equations. Trig equations involving multiple angles. Okay, so let's just recall what I was just saying at the very beginning here. In the previous section, you had to solve something that looked like this. This had a multiple angle, 2 theta plus cosine theta equals 0. So this is an actual example that we did in the last video. So here in the last video, we actually rewrote this cosine 2 theta. So this is what they mean by multiple angles. So your theta is being multiplied by some constant, right? So here we learned how to deal with this by rewriting it using the double angle formula. And that was fine and dandy. So now what we're doing is we're going to take a look at, okay, suppose that doesn't work, or when we do that, it doesn't make anything easier about the equation. Okay, and we did that in the previous section because we wanted to get not just the same trig function here, but we also wanted to have the same angle. So we used the double angle formula, okay? So now it's going to be the case where, okay, well, we just have the cosine 2 theta. We don't have this one. So do we still use the double angle formula, or can we address this without having to do the double angle formula? And the answer is yes, you can. Okay. All right. So about multiple angles. So what's going to happen here is so you might have theta, like cosine theta, or maybe you have cosine 2 theta, or maybe you have cosine 3 theta, or just some multiple of theta, right? So what happens is when you just have a single theta, like this one over here that you're trying to solve for, then and then what happens is you're looking for the answers theta that are between 0 and 360. Okay, and then here for 2 theta, you're looking for the answers between 0 and 2 times 360, which is 720. Okay, so what's happening is, like here in this first one, this is like you find all the answers, all the solutions, all the angles in one circle. So from 0 to 360, one circle of answers. That's what you're doing here. And then in this next one, it's like you're finding 2 circles worth of answers. So you find all the answers in the first circle from 0 to 360, and then you find the next set of answers from 360 to 720. Okay, and then here, this one would be a third circle. So this would be this would add 360, 1080. So here, this is 3 circles worth. And we could just keep going with the same pattern. And you'll see what I mean when I about these 1 circle of answers, 2 circles of answers, 3 circles of answers. And we can keep going. So then here, whatever n is, we are finding all the angles between 0 and 360 times that n. Okay. And this is just n circles. So maybe you have 5 or 10. We're not going to go that high, even though it's possible. Okay. Okay, so let's take a look at an example of what I mean. Okay, so suppose that we are trying to solve cosine 2 theta, which equals square root 3 over 2 if theta is between 0 and 360. Okay, so here, because it's a multiple of 2, that means we're going to find 2 circles of answers. Okay, all right, so here, cosine 2 theta equals square root 3 over 2. So 2 theta uh, must be the angle. You should have these memorized, right? So square root 3 over 2, that happens here in this quadrant, quadrant 1, and in this quadrant over here. And we know that the angle is going to be 30 degrees, right? And again, it's bounded between 0 and 360, so we can't have any negative answers. So we want this very large angle here, which is 330. Okay, so this one here is 330. So here, I'm going to go ahead and list these two answers, 30 degrees and 330 degrees. Okay, and these are my answers in the first circle. Okay, so this is my first circle of answers. Okay, now I want to go, because this is 2 theta, I want to go a second circle of answers. Okay, so a second circle of answers. And the way you can do that is you can just add 360 to both of these, right? To get the next set, okay? So if you add 360, you get 390. If you add 360 here, you get 690. Okay, so now we actually have 4 answers, but we have to solve for theta. So if you want to solve for theta, you have to cancel out this multiplier of 2. So you would have to divide both sides by 2. So we're going to divide both sides by 2. So we're going to divide this by 2, and we're going to divide each of these 4 by 2. And the reason why is because if we just look at the answers right now, we see that these 2 over here exceed our boundary, which is our angles have to be somewhere between 0 and 360. And it says theta, okay? But you have to remember, this is 2 theta, okay? If we solve for theta by dividing both sides by 2, then I get theta equals 30 divided by 2 is 15. 330 divided by 2 is 165. No, it's not. It's what am I doing? It's 115. Okay, so 115. 115. No, it's not. Okay, so I was right. Okay, so it's 165. All right, 165. Okay, and then if I do 390 divided by 2, then I get 195. And if I do 690 divided by 2, I get 345. Okay, so here, when we have it set 2 theta equals these 4, clearly we are outside of 360. But when we solve for theta, divide all of them by 2 to solve for theta, you'll see that all of them, all 4 of these, are within these boundaries between 0 and 360. Okay, so that's how it works. Okay, so had this been 3 theta, then I would have to find a third circle of answers. And to do that, again, we found these two by adding 360 because they're going to have the same reference angle, right? So if I had to do a third a third circle of answers, then I would just go ahead and add 360 to these to get my third circle of answers. Okay, but we don't, because this is 2. If this were 3, I would need a third circle. If this were 4, then I would need a fourth circle of answers. Okay. Okay. Let's try another one. Oh, so over here, the difference between this problem and the problem that we did before that had a cosine 2 theta. So we use a double angle formula here. And the reason why we did that was because we had 2 different angles here for cosine. We had one that's just theta and one that's 2 theta. And using the double angle formula gets us down to just a cosine theta that we can work with here in the equation instead of these 2 different ones. Okay. But over here, we didn't have to worry about cosine of some other angle that's not 2 theta. So we went ahead and just kept it. We didn't use the double angle formula. We just went ahead and found 2 circles worth of answers and then solved for theta. All right, so let's go ahead and take a look at this next example. Let's go ahead and solve cosine 2x, cosine 2x, cosine x, minus sine 2x, minus sine 2x sine x, okay, equals 1/2, and x is between 0 and 2 pi, so radians. Okay, so here we've seen this this structure before, this format here before. Here, let me do this. So let's recall from the sum and difference formulas. If you remember, cosine A, cosine B, minus sine A, sine B. This here goes with cosine of the sum. Okay, so this here is the one that we're going to use to rewrite this one over here. Okay, so in this case, A is 2x, B is x. So we see that A is 2x, B is x. Okay, all right, so let's go ahead and rewrite the equation here. Let me copy it down first so we don't lose it. Minus sine 2x sine x equals 1/2. Okay, all right, so we're going to go ahead and rewrite this. All of this becomes cosine of A, which is 2x, plus B, which is x, equals 1/2. Okay, so 2x plus x is actually 3x. Okay, so here we don't have any other cosine of some other angle, so we're just going to go ahead and keep this cosine 3x, and we'll just find 3 circles worth of answers. Okay, all right, so cosine is positive here, and it's positive 1/2 at 60 degrees, but we want radians. Okay, 60 degrees, so pi over 3. And then we can't say negative pi over 3 because we're bounded at 0. So it's the large one over here. So this one is 5 pi over 3. Okay. All right, so let's write that down. So at 3x, not x yet. Okay, 3x equals pi over 3 and 5 pi over 3. Okay, so this is my first circle. And we need to do 3 circles. Okay. Here, I'm going to go ahead and just draw my thirds. Okay, so this is 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So the second circle of answers will be 7/3. 7, 8, 9, 10, 11. So this is my second circle. If I go another circle, so we left off on 11. This is 12, 13. I'm on my third circle here, okay? That's 13, 14, 15, 16, 17. Okay. All right, so I have these here. So I did my 3 circles of answers because our multiple is 3. Okay, so now I can solve for x, divide everything by 3, or multiply everything by 1/3. Either way, it's the same thing. So if I divide everything by 3, I get pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Okay. All right. And we can see here that this is just shy of 2 pi. And that is our restriction. Your x values should be somewhere between 0 and 2 pi. And all of these are between 0 and 2 pi because this would need to be 18 in order for this to be 2 pi, right? Okay, so these are our solutions. So we see here that, yes, we start off being outside of 2 pi, but once we divide everything by the multiplier, we end up being within our restrictions. Okay? All right. Let's see. Let's go ahead and let's do this one. Solve 4 sine squared 2 theta minus 3 equals 0 if theta is between 0 and 360. Okay, so let's go ahead and write this down below here. Sine squared 2 theta minus 3 equals 0. Okay, so I'm going to go ahead and add 3 to both sides. That way I can get the sine, the trig function by itself. Divide both sides by 4. Get 3 over 4. And now take the square root of both sides. Okay, so we're going to take the square root of both sides. And that will give me sine 2 theta equals plus minus the square root of 3 over 4. But then that will give me sine 2 theta, which equals plus minus square root of 3 stays. Square root of 4 is 2. Okay. All right, so square root 3 over 2. And we are in degrees. Okay, so that is going to be 60 degrees, right? So 60 degrees and then 120 degrees. And it's going to come from all 4 quadrants because we have positive and negative. Okay, so those are the positive ones. The negative ones are going to be 240 degrees and 300 degrees. Okay, so these are my answers in the first circle. Okay, so let's go ahead and write that down. Okay, so 2 theta equals 60, 120, 240, and 300. Okay, so this is my first circle. And now I need my second circle, so I can just add 360 to all of these. so that my next list is 420, 480, 600, and 660. Okay, and I only need to do a second circle, not a third, because our multiplier is 2. If it were 3, then I would need a third circle, okay, of answers. Okay, so now we have everything. Clearly, we're outside of our 360 range, but that's okay because we are at 2 theta, not theta. So now let's solve for theta. Divide everything by 2. If I divide here, I get theta. And then if I divide everything by 2, I get 30, 60, 120, 150, 210, 240, 300, and 330. And clearly, all of these angles here are within our restriction. They are bounded. All of these are between 0 degrees and 360. Okay, so they all fall within the range. Okay, let's try another one. All right, so let's go ahead and solve sine theta minus cosine theta equals 1 if x is, or if theta is between 0 and 360. Okay. All right, so let me write this down. Sine theta minus cosine theta equals 1. Okay, so this is no fun having two different trig functions, so we could try to rewrite, but we don't really have anything unless we introduce square roots, but introducing square roots is never really a good idea. All right, so let's try one of those other strategies that we learned in the last section, which was squaring both sides. Okay, so let's square this side and let's square that side. And remember, when we square both sides, if you watch that video, the one where I left to go answer the door, right? And you guys all patiently on the edge of your seat waited to see if I was going to get mugged or something while answering that door. Okay, anyway, that one, if you tuned out and you just went ahead and stopped watching, there was an important note at the very end about what you need to do if you are using the squaring both sides method. When you're squaring both sides, if you're using this method of squaring both sides, you have to check your solutions because there's a good chance that your list of solutions contains extraneous solutions, which means they are solutions that you found but don't actually work. Okay. All right, so let's take a look. Here, this gives us sine squared theta. Here, let me put a note. Remember to check final solutions when using this method. Using this method. Okay, so sine squared minus 2 sine theta cosine theta plus cosine squared equals 1. 1 squared is 1. All right, so we have a sine squared plus cosine squared. That's a 1. Minus 2 sine theta cosine theta, which equals 1. This is double angle for sine. So 1 minus sine 2 theta. Solving for sine, subtract 1 on both sides, and I get 0. And so divide both sides by -1. I still get 0. Okay, so I have this here. All right, so let's see. Sine 2 theta equals 0. When does that happen? So that happens here, 0 degrees. Okay. Are we in? We are in degree mode. Okay, so at 0 degrees and at 180 degrees. Okay, this is my first circle. My second circle, we need 2 circles of answers because we are 2 theta. So 0 plus 360 is 360. And then here, if I add 360 here, I get 540. Okay. And now I can go ahead and divide both sides by theta by 2 to solve for theta. So divide by 2, we get theta. Divide these 4 by 2, and we get 0 degrees, 90 degrees, 180 degrees, and what is this, 270? 270 degrees. Okay, so we have to check these. Okay, we have these 4 answers. So let's do our checks. All right, so the original equation. Okay, so sine theta minus cosine theta equals 1. So let's try 0 degrees. Sine of 0 minus cosine 0 equals 1. Question mark. Sine of 0 is 0. Cosine of 0 is 1. So does this equal 1? No. Okay, so this is not an answer. All right, let's try 90. All right, so sine of 90 degrees minus cosine 90 degrees. Does this equal 1? Sine of 90 degrees is 1. Cosine of 90 degrees is 0. So does this equal 1? It sure does. Okay, so 90 degrees is one of our answers. All right, let's check 180. Okay, so sine of 180 degrees minus cosine 180 degrees. Does this equal 1? Sine of 180 is 0. Cosine of 180 is negative 1. So does this equal 1? Yes, it does. Okay, so theta equals 180 works. And let's check the last one, 270 degrees. So sine of 270 degrees minus cosine of 270 degrees. Does this equal 1? Sine of 270 is negative 1. Cosine of 270 is 0. So does this equal 1? No, it does not. So this one is eliminated. Okay, so this is why you need to do your checks if you're using the squaring both sides method. Okay. All right. Okay. Let's see now. Okay, let's do one more. Let's do one more. One more and we'll call it a day. All right, so suppose that you have to solve sine theta minus cosine theta equals square root 2. Okay, if theta is between 0 and 360. Okay. All right, so we have sine theta. Why don't you try this one on your own and then come back and see if you get the same answer. Okay, so here, this is going to be very similar to the last one, the initial step, because we can't really do anything here, any rewriting of one or the other, unless we introduce radicals, and who wants to do that, right? Okay, all right, so we are going to use the squaring method again. So we get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta equals 2. And so because we're using the squaring method, we have to check final solutions. Okay. Because remember the lightning. See, those of you guys who I can't even draw it anymore. Ooh, those of you guys who stuck around for that video where I went downstairs to open the door, you know what I'm talking about. Okay. All right. Anyway, sine squared plus cosine squared is 1. Okay, so subtract 1 on both sides. So I get negative 2 sine theta cosine theta equals 2 minus 1 is 1. Divide both sides by negative 2. Sine theta cosine theta equals negative 1 half. Okay. Oh, okay. So this is an alternate way of doing this. Okay. So we could do it this way. And, but, so this is what I was talking about how, okay, if you have, we cannot say sine theta equals negative 1 half cosine theta equals negative 1 half and then solve that way. We can only do that when it's set equal to 0. Okay. So let's not do this step. Don't be mad. Okay. All right. So here, I'm going to go ahead and get rid of the negative on the side. So I get 2 sine theta cosine theta equals negative 1. And this here is actually our double angle. So I am going to use the double angle here for sine. Okay. All right. So that is sine 2 theta. And that equals negative 1. And sine equals negative 1 down here at 270. Are we in? Yeah, degrees. Okay, so 2 theta equals 270 degrees. And that's our first circle. And we only have the 1. We need a second circle because our multiplier is 2. So if we add 360 to this, then we get 630 is our second one. Okay. All right. So those are our only ones. So now we can solve for theta. Divide both sides by 2. So theta equals 270 divided by 2 is 135. 630. This looks like a 6. Let me fix that. 630 divided by 2 is 315. But now we have to do our checks. Let's see if any of these are extraneous. All right, so let's do 135 degrees. All right, so the original problem, sine minus cosine equals square root 2. Sine of 135 minus cosine 135, does this equal square root 2? Okay, sine of 135 is over here. So sine is positive, square root 2 over 2. And cosine will be negative square root 2 over 2. Okay, so we want to know, do we get square root 2? So here we get square root 2 over 2 plus square root 2 over 2. So does this equal square root 2 over 2? Well, 1 half plus a half is 1. So we do get square root 2. Okay, so this is one of our answers. Let's check the other one, 315 degrees. I'll do it over here. Theta equals 315 degrees. All right, so sine 315 degrees minus cosine 315 degrees. Does this equal square root 2? Okay, 315 degrees is here. So sine is going to be negative square root 2 over 2. And cosine will be positive square root 2 over 2. Okay, so does this equal square root 2 over 2? Here we get negative square root 2. So no, they are not equal. So this one is not going to be a solution. This one is. Okay. All right. So that is it. Don't forget, again, when you're using the squaring method, you have to make sure you check your final solutions. Okay. All right. If you have any questions, make sure you text me or email me. Make sure you are keeping up with the homework assignments on WebAssign, and make sure you are checking in for attendance on Canvas.